Okay, so just to start, I'm just going to define, just let me get this working again. Okay, so bash is, does anyone know what a shell is? Or like kind of a broad definition of what a shell is? So a shell is kind of like an interpreter or an interface between us and the computer. So you can imagine that on your phone, when you open up a GUI, that's also a shell because it's one way that you interact with a machine and give it information to like communicate with it to give instructions for what you want it to do. In this case, bash stands for born again shell, and I don't remember all the history about it, but there's a man named, I think, not Jason Bourne, but I think it was like Jonathan Bourne or Brandon Bourne, I don't remember his name, but he reinvented this new shell that a lot of people took on, and there's many different other shells like ZSH, or I don't know how other people use that. There's different types of shells that you can use, but this is a common one that people use. And it's automatically included on, I think, Macs and Linux computers. But I think on Windows, you can have git bash, which uses bash as well, or you can have bash installed, or I think by default, you can have it used on Windows 10 and forward. So does everyone know how to open an interpreter or a bash shell? If you don't, maybe Elliot can come help you. So yeah.
Is there any differences between the terminals?
Yeah, I don't know what the exact differences are. Sometimes the way they go about naming commands or how to get help or how to do command flags might be different. But I think a lot of the times, like a lot of them have like CD, which is change directories, or there are little like quirks that each of them have that make them better or worse. But yeah, I don't know the exact details. Okay. So if you can just open a shell, for me, what you can do is if you're on a Linux machine, you can do Control-Alt-T. If you're on a Mac, you can search your apps for something called terminal. Some people use iTerm too, which might be a little bit more similar to the Linux setup of bash, but either way, if you have one open, that's great. So we'll just get started. So the very first thing that we're going to do is we're going to go very simple, and we're going to progress to a script at the end. So we're going to start with just looking at some simple, looking at our files that we have in our system directory, because that's one thing that we can do when we're interacting with our terminals. We can look at what's actually on the computer. Okay, so the first thing you're going to type wherever you are automatically, I'm in my desktop, but I'm just going to do ls, and I have all these different random things, which I guess I didn't need to have here. And if you do ls dash, I don't actually have any files, so I'm going to go in, I'm going to make some files. Let's just do ls dash t. So that's going to sort by the time that it was created. So what I have here is ls is a command, and then after I can have some flags. So flags are kind of like arguments that you pass to the command ls. So in this case, this dash t tells ls to list my files in chronological order. And if I do ls dash t r, the r means do it in reverse. So now it's reverse. You can see the order is different. So that means that this was produced most recently, and then it goes to in reverse chronological order. So when you have multiple command flags, these are also called flags, you can just chunk them together. And it doesn't matter if you do ls-rt. Don't think so? Yeah, you can put them in either order, and they'll just kind of run it all at once, and you don't need to separate them. But another way you can do it is like this, -t, and it'll do the same thing. So you can either separate them or combine them. It's a little bit nicer. It's just quicker to do them all together, but sometimes for different purposes, you might need to separate them. And I'll get into that later. So you might be asking yourself, sure, like you told us that T means like time and R means reverse chronological order. How do I find out all the different flags that are possible? And there's a really simple way you can do this. Most computers should be able to, most bash should be able to do this, but if you do ls-help, this is really the only one you need to remember, because then if you go through, doesn't work. Maybe it does. Oh, it does, okay. So if you scroll up, it's just because my font's really big. You can see all the different flags and what they mean. So for here, P stands for append indicator to your directory. Let's look at one that makes a little bit more sense. -L means use a long listing format. So let's just try that. I'm going to go to the, and if that didn't work, you can put up your hand. I'll show you another way that you can get it to work. It's all good? Okay. So I'm going to just go down, and I'm going to do ls -L, and you can see that now this is this long format, which shows me like my read-write access, who owns it, the user account that it was created by, and then a little bit more information for each file. That might be more useful sometimes depending on what you're looking for, like if you just want to see file size or something like that. Okay, so you always, another way you can look at the manual for how a function works is using the man. Can everyone see at the bottom here? It's okay. So the man, which means manual, and then ls. And then it's going to open up kind of like this view that's not necessarily, it's not in your actual terminal, but it's a view in your terminal that you can like scroll through and look through a little bit more nicely. And if you want to get out of that, you can just press Q. Everyone good? And you can do that for any of the commands that I showed today. If you want to learn more about what they do on your own time, you can just do man and then the command. Okay. So let's get into just kind of traversing directories and files. So I don't know where you are on your computer. I'm assuming it could be your documents, my documents, your main computer, or for me, it's my desktop. So one way you can find out where you are is to just type pwd, which means print working directory. Okay, and then for me, it says I'm in my desktop. Right? So for you guys, there'll be obviously something different. And notice, I just wanted to make a note of this formatting for directories. So when it has a slash in the front, like this might be super obvious to some of you, but when it has a slash in the front, it means that it's going from the very root of your drive, and then it tells you all the folders that get to it. But you'll see in a little bit in a bit that we don't always need to use absolute paths. One thing that we can do is, let's just start by making a directory that we can work inside, and we'll show a little bit of these types of concepts. So one way we can make a directory is do mmake, which is mkdir, and then let's call it bash lesson. If you're okay with having it in this folder, we can delete it or move it after, but for now we'll have it here. So name of the folder, and then we're just gonna press enter. Oh, because I already have this folder. So I've already made it, but for you guys, it should work. So, and then I'm gonna go into a directory. So from where you are, if you just made it, then you should be able to go into it by doing cd, which change directory, bash _ lesson. Does that work for everybody? Good, okay. Great, so now let's print our working directory again, and we should see that it should be one level in, which is in our bash directory, our bash lesson directory, right? So if you want to go back out, you can type out this entire thing like cd and then whatever, everything up until the bash lesson. So you can try doing that, but maybe it's a really long convoluted path. So for me, it's not too bad. I can do this, right? You don't have to do this right now. I'm just going to show you. And I'm back into my desktop. If I print my working directory, I'm back, but I'm just going to cd back into my bash lesson. So back to where you guys are. Another way you can go back up one level is to do cd and then space, dot, note, and no spaces in between the dots. Okay, so notice that I went back up a level. So where I was basically inside of a folder here, and to get back here, I can write the full path that's including this, but one way to go just up one level is to go dot, and if I want to go back up like 2 levels or 3 levels, there's nothing to stop me from doing that using the same notation. So I can go up 3 levels. In this case, I'm at root. So if I print my working directory, it doesn't say anything because I'm at root, which is actually like the start of my drive. But I'm going to change back to my, my working folder, which this is a shortcut for me. I'm not sure how this will work for you, but if you do this, you can get back to your default, where you default, where your terminal opens by default. And that's a tilde and a /. You don't actually need the /, but you can have just the tilde. So I'm back to this, and if I print my working directory, I'm here, I'm at home, Lena, but I really want to be back in my desktop because that's where I was, right? So one way I can do it is do cd. I'm going to use that again. Depending on where you probably were already in that folder, so just stay there, but I just need to get back into my desktop. So I'm here, and if I print my working directory, I'm back here. Okay, so I went back 3 levels up to root, then I went to where my default, so let's say this is my default level, then I went back here, and then now I want to go back into desktop, right? So you can think of it as you can traverse using absolute paths, which would just say root / folder 1 / folder 3, or you can do it using relative paths, okay? So let's try to go back into our, is anyone not in your, where you started? Everyone's okay? Okay, so let's go back into our bash lesson and do some things there. And notice that I just auto-completed that. I don't know if it's a little bit something that I use every day is just this autocomplete using tab, and this is pretty common in other programming languages or scripting languages, where if I just have a few letters, it'll kind of autocomplete if nothing else, if there is something that matches with those starting letters, okay? So I'm gonna enter, and I'm back into print working directory again, just remind ourselves where we are, and we're back into the bash lesson folder. And let's just start making some, let's use some stuff making some files. So let's make a file by using the command touch. Touch just makes a file. It starts it off empty. So this is just setting up a file. And you might need to do other things. There are other ways to make files, but this is one way to start an empty file. And I'll call it file a.text. For now, you can keep it the same as me, just so that we can have all the same commands. But if you feel a bit more comfortable, you can name it whatever you want. So I press enter. And then if I do something called, if you remember that first command we did, which is list the files, you should see ls gives us file a.text. Because we just made this folder. There shouldn't be anything in it except this file that we just made. And if we want to make, and I'm going to, so that's pretty simple. You can make a file. You can see it. If we want to, I just want to show some more nice commands for searching for files of different types. So I'll show you what that means. Let's make two more files. Touch file underscore b.md this time for markdown, and then another file, touch file c.markdown, and then another one. So we'll have a total of 4 files. You'll see why I'm doing this in a second. .text. Okay, so try to keep it similar. Yeah.
Typo, how do I delete it?
Control you. Oh, okay. Okay, so you can remove a file doing rm, and then file whatever it was called, the full name, as long as you're in the right folder. Okay. So we'll get to rm in a bit, but for now, we have these 4 files. We can check by doing ls, right? Should have 4 files, example.text, file A, file B, file C. Okay. So ls has been listing all the files right now, right? But what if we only want to see the ones that are markdown files, the ones that end in md? So you guys might be familiar with this notation, but what you can do is use star. It's like a glob pattern. So use star to indicate anything that matches up until that matches .md and anything before that. So anything before that can be like 1 word or 2 characters or 4 characters, doesn't really matter, as long as it ends in .md. And if we ls, you should get file B and file C, right? So that might be really useful for you when you're looking for all your Python scripts in a folder and you just want to do ls-star.py. So for example, I don't have any Python files here, so it's going to give me an error, cannot find any files or directories like that. So that's how you might look for all your Python files or your R files, whatever you're looking for. Okay, so that's pretty straight. That's the one I use the most. You can also do, you can also put it at the end. It doesn't need to be at the start. So let's say we do ls file underscore star. It'll find me all the files that start with the words file underscore. That's pretty useful. And then finally, if we have something where we just want one character to change, because maybe you have a lot of different files and you don't want to get the wrong ones, you can do ls file underscore question mark dot text. But you really only want the files. So in this case, it's useful to have the files that we had because it will demonstrate this where this is like a wildcard. So it's a 1-character wildcard, and it can be anything. So file A, B, or file A only, and not B and C, right? Because it has to be a text file, and it also has to have file A, have the word file in it. Okay. Another thing that will be useful is if you have a list of, like, let's say we only want file A or C. They're different endings and they start the same, but we don't want file B. That's a little bit hard to figure out how to do that, right? But there's a useful little command called notation where you can do file underscore wildcard. Not wildcard, you give it like a list of what it can be. So it could either be an A or a C there, and then I want dot star because I don't care what it ends in, I just want the A or the C. And that should give you text file A and file C. Does that make sense? So that's a useful one if you say you have a ton of files named file 1, file 2, file 3, file 5, and you want, yeah, sorry.
Question.
Yeah.
So if we use that command,
yeah.
if you have a file named file-ac, will that come up as well? Yeah, or
I think because you would have to have, because it'll look at these as individuals and it'll look for either an A or a C, it won't look for AC. You would have to use a different string match character to match AC, I think.
Oh,
but we can try that right now actually. Let's just make a touch file underscore AC dot MD, and then I'll run, oh, and if you want to go back to a command you've already pressed, you could just press up or down and it'll kind of go through your history. So that's kind of a useful thing if you forgot to press something. So I'm going to try this again, and it doesn't show it, right? Okay, so I'm just going to remove that file. Yeah, so now we've gone over it. So RM is just remove. I'm going to just remove that file right now. Okay, so those are just kind of like pattern matching for like listing files. Of course, we'd want to do some more nice things. We don't want to always just find files. We might want to look inside files. For now, all our files we just made are empty. We can tell because if we look at this thing called cat, I can't remember what cat stands for. Is it concatenate? Okay, so cat file underscore a dot text. There's nothing in it, so it prints nothing. Let's put, I'm going to show you something really quick. If we do echo and then write hello universe, because that's the thing everyone always writes. I don't really remember why. It'll print out hello universe, right? So echo just says print, echo is like print out the following words. And you usually have it in quotes in case there's like spaces and things like that. What's really useful is we can actually put that output, we can put any output that happens in the terminal into a file by using this notation here. So if we do echo hello universe, I'm just going to go up because it's going to automatically fill that for me because I already wrote that. Just going to put this here. And then the arrow, the right arrow, and then file a.text. In this case, it's going to overwrite whatever we have in file a.text. We actually have nothing in it, so it doesn't matter. And put hello universe into file a.text. How do we know that it did that? We can use that cat function again and do file a.text. So make use of that tab, you know, like don't type as much as if you don't have to. And it says hello universe. So now we put something inside a file. So you can imagine if you have, you just want to, if you want to append as opposed to overwrite something, we can do echo hello universe, and append. This doesn't overwrite the file. It'll actually add to the bottom of that file. So we can take a look at what that does. So we can now cat again, file a.text, and now it has 2 lines of hello universe, right? You can see the difference because if I do echo hello universe again and I take out one of the arrows, what do you think will happen to file a.text? What will it look like? 1 line that just says hello universe, a.text, because it just overwrote it and it didn't add to the end. So there's reasons why you might want to do that, or reasons why you might want to append, right? Okay. So, and at the end, okay. Just copy what I'm doing right now, and then we'll see why we're doing it in a second. We're going to echo again, and then we're going to make a list of animals. So you need to start with that echo space apostrophe, and I'm going to start with the dog and press enter. And what that's going to do is going to enter onto a new line so that you can, because it's within a string, right? So it just knows that you're going to try to make a multi-line string. So you can put whatever animals you want. Let's do at least 5 or 6. So I'm just going to do dog, cat. I actually like cats more than dogs. So I don't know why I put that first. Let's see, octopus and starfish. You can stop whenever you get to 5 or 6. I'm just going to get to snail, and then I'm done. Okay, and then you can put, so whenever you're done, don't press enter. It'll probably put you to a new line. What you can do is put an apostrophe to end the string, like there. Or what you might get is maybe you already pressed enter and you're here. You can also put an apostrophe there and end it. And then put a right arrow to put it into a file. And we're going to call it animals.txt. Okay? Anyone having issues with that so far? So now let's ls again just to see that our animals.txt file is there, and it is. So by default, I think ls will always do things alphabetically. So that's why you might want to do things by time that modified or file size or something like that. Okay, anyways. So we have this animals.txt. We can look at it by using cat.animals.txt, right? What we might want to do sometimes is not look at the whole list, but just look at the first 2 lines. Imagine you have a huge list of like data, and you just want to take a look at the first 2 lines without opening up a CSV or an Excel. You just want to look at it. What might be useful is doing the head function, which maybe if you use Python or R, you would know that that gives you the first 5 or so lines. It depends on the number changes, but it will give you the first few lines of something. So if we do head animals.txt, you'll see that it gives us the whole list because I think, oh, yeah, it does. I don't know what the default is. It might be 10 or so. But if we do head and then -2 animals.txt, it'll give us the first 2. So that's another flag that we use. That is a command for head that says, give us the first 2. And you can change that to 3, 4, 5, 6, etc. Same thing with tail -3. They'll give me the last 3 lines of animals.txt, which is, it's weird. Oh, because I actually had another, it's an empty line. So that's why you're seeing that there. Okay, so one thing that's interesting is if we want to look for something in there, we can, let's say we want to look for a string that we know ahead of time we're looking for. You can use something called grep. And then if you do the string that you're looking for and where you are looking for it, which is animals.txt, you can get the two occurrences of the word fish that I have here. You might only have one because I don't know what you're looking for in your files. Maybe we should have kept it the same for this purpose. But so we have fish and starfish, and I'll actually kind of highlight for you the thing that you're looking for. And then this is going to lead us into a command that is really useful, and it's a way to chain commands onto each other. So it's the idea of piping. So if you came to the R lesson last week, we saw the magical pipe command in I can't remember what, Magrider, I think, in R. And what that does is it takes the output of one, throws it into the next function, next command, so that you don't have to type multiple lines and save it into temporary variables and things like that. So let's say we want to do the grep fish animals. So just type something that you can find in your text. And what we're going to do is pipe it using, so I'm doing shift, and for me I have the shift and it's above the backslash or something like that. It gives me this pipe here, so just find where that is on your computer. Do the pipe space, and we're going to do word count -L. I have an apostrophe where I don't need it. So I'm going to go back and correct that. Sorry about that. And it's going to tell me that the number of words in which there's fish is 2. 2 lines, yes. 2 lines in which, so if I did -W, it would be words? Okay. Well, either way, it will give the same answer. So -L would be lines in which this word occurs, or string occurs, and W would be how many times this word occurs, regardless of if it happens on multiple lines or on the same line. Okay. So what if we want to put this search into another file called list of fish? So I'm just going to, for now, we'll just do grep fish of animals.txt, and then put it into another file called list of fish. And that's ls, so it's right there. And, oh, yeah, there it is, cat list of fish, and it gives me fish and starfish, right? I can also go back and do this other command that involves a pipe, and then take that output and then put it into a file. So here we're looking for the string fish in animals.txt. We're going to pipe it through to the word count, and we only want the number of, let's say, lines in this case, because every animal is on a different line, and we want to put that into a file called number of fish. And if we ls, we can see that there, and we can cat number of fish should be, for me, 2. Okay? So that's pretty it's a pretty good overview of how you can look through files, look for strings, or look for match things. And you can also use these to make new files, take the input of those results and put them into other files. Okay, so a few more useful things that are useful in terms of making new files. If you have two files and you want to concatenate them into one file, you just do cat. I guess that makes sense that it's called concatenate. So cat, let's say file A dot text, which should be our hello universe, and our number of fish. And then we'll put it into a new file called combined dot. It doesn't really need to have the end, but here we will have it. And we can look at combined.text. And now it has hello universe and the number 2, which is the number of fish that I had. And that's a pretty quick way to just combine two files. If you and the order in which you do it is important. The first file will be first and the second file will be second, right? Okay. And another useful thing is if you want to just do a quick search and replace, this is very powerful. I'm not going to go too into it because regular expressions are like a whole entire lesson on their own. But what you can do is use the sed dash e. Okay. Let's just do, yeah, for I think, yeah, just follow this. So s just tells you s / and then we want to replace the word cat. Let's just do actually dog and replace it with the word cat. Why not? And I'm going to do it, I'm going to give it the animals.text. So this is a different notation. What I was doing before was using a pipe to indicate when something goes into another thing, or the right arrow to indicate when an output goes into a file. In this case, we're doing the opposite, where we're taking animals.text and sending it into this command. So you can see that there's like this bidirectional use of these arrows, right? So I'm taking animals.text, putting it in this command. And then we can take that output, whatever gets output from this first part, and put it into a no dogs.text. I don't hate dogs, I just like cats more. And then we can look at cat and no dogs.text, and we see that cat, fish, octopus, starfish, no. Okay. So that's one, just kind of like a quick overview. What you might want to do sometimes is make variables in your environment space so that you can use them later. We'll get into more examples of how you can use it in a second, but for now, let's just make a variable called my_num. Do not put any spaces here. You need to do them without spaces. So I'm just going to do 73, for example. Let's, for example, if we do put a space, what will happen? Equals 73. It'll think that my number is like a command, because that's sort of how we've done things so far. Is we have a word, which is our command, and a space, and then followed by different arguments or different flags. So in this case, it gets confused. So you need to put it all together so that you know that you're setting a variable. So in this case, just do my num underscore num equals 73. And then let's do another one. And then, yeah, that's fine. And we can echo my num. So that's going to cause an error, but I just want to show you why. It'll just echo my num because it thinks it's a string that you're trying to print, right? So how do you tell it that it's not just a string you're trying to print, like hello, echo hello universe, or hello universe. So that makes sense that it should do that because we don't have anything called hello universe. But if we want to actually print the value stored in my num, you need this $ symbol to indicate that you're calling a variable. And then it should give you the output, which is 73, or whatever you stored in your variable. Okay. So the last thing, or maybe not the last thing, but one of the last things I want to go over is loops. You can imagine this is very useful in scripting, just like a basic concept that we should be able to make use of. So there's a syntax to how you would make a loop. So just follow along for a second, and then I'll get into what's happening. So for I in 1 space 2 space 3 space 4, I'm going to do a semicolon and then a space do. You got for I in 1, 2, 3, 4 with spaces and a semicolon, space do, press enter. It should kind of do that thing where it's almost onto a new line. So it's not done yet. It knows that it needs something to end this loop. So we're going to press space 4 times, 1, 2, 3, 4. We need to indent. And then I'm just going to print each of these items. So I'm going to do echo the value of I. Sorry, I'm just going to take out this apostrophe. The value of I is. You see why it's useful that it doesn't always just print when you have the word I, right? Because you might want to actually use that and not. So yeah, we'll see what that does in a second. And then I'm going to press enter, and it's going to bring you back to another line. And we're just going to type done. And let's see what it does. And it says the value of I is 1, value of I is 2, value of I is 3. It loops through it and prints that statement, does this thing. That's why it says do this, and then be done when you've gone through all the numbers. Okay. So typically, we're not just going to be looping over random numbers and printing them. For example, you might want to loop over files. So this is where we can make use of other commands that we know, such as ls. So for I in ls, so list all, right, of the files. That, do you remember what this does? It's kind of like that wildcard for matching anything. Dot text files, and then do. So remember, you need that semicolon there. You need a space and a do. Press enter. So for every file that matches this the search, we're just going to echo the name of the file, which is going to be captured in I, because ls is going to get file names. Sorry, we actually need 4 spaces. 3, 4. Press enter again. 1, 2, 3, 4. Cat. And then we're going to print what's inside inside that file name, right? And then we're going to press enter and then done. So let's see what we get. So you should get a lot of things, but because we have a few files. But so first it says cat, no such file or directory, animals.txt. So it goes through and has animals.txt. It goes through the animals.txt, then combine.txt, then example.txt, and should have it all. I'm trying to figure out why this error came. Cat. I do? Oh, here. Right, sorry. I must have typed that again. Okay. So that will loop over your files. And for example, you might want to, for every file, you might want to replace a certain word in all of them and do that search that I had shown earlier. Okay, so one quick thing that might be useful is that you might want to write a script that saves a ton of commands and then runs it every single time. So one thing that I use this for is I have to update my lab's website. And what I do is it has to run a couple of commands like over and over again. And it just updates our Git page and then renames things and then gets them all in the right order. So I might save that in a script and run it over and over again. So if we want to do that, you can, can you try typing nano myscript.sh? I think that should work on most of your computers, but might not. Anyone have problems? It was nano space, sorry, I'll just exit out of this. So it's nano and then a name of the script.sh. It's fine. Okay, so it should open up this kind of like view again inside your terminal. And what we're going to do is write a little script that does something. So I'm just going to echo. So what I wanted to do is print out the following statement. The first argument is 1. And then echo all of the arguments are. And then for I in argument star. I'll explain this in a second what I'm doing with these arguments. Let's do echo I and done. So I'll just leave this up for a second just to make sure that, and I spelled that argument's wrong. Okay, so what we're doing here is we're going to first this is a script. So what it'll do is you can give a script, when you run a script, you can give it some arguments, right? Just like those flags that we had before, you can give it, instead of flags, you're giving it arguments, like other file names or things like that. So how you access arguments that get given to a script are with this $sign again, because those are like variables. If you do argument number 1, it's going to take the first argument that we give it. So just keep this in mind when we actually run this script in a second. And then I'm going to do a for loop where it prints out, for every argument given, print it out, and then you're done. Okay, so how to get out of this view is if you look at the bottom, you can see that Shift X is going to be our exit. So, and it's actually, I think it's Control Shift X, but is it Shift X? No, okay, sorry, Control X, and then it's going to say save modified buffer, say yes, so Y, and then press enter. Is that okay? Because I know that's been a little confusing sometimes with Nano. So now you should have a script, something called my script. You can look at it, and it should look very much like what we type in, right? And then let's try to run it. So what you do is you write bash my script.sh. And I'm going to give it some commands before you press enter. So I'm just going to say first, then, well, that's not that interesting, but first, second, and third, just to be simple. And then we see that what happens, so we just compare this to what actually gets output, right? So you have what the first echo was, which is the first argument is first, which is what the first one was that we gave it. And then it says all of the arguments are first, second, and third, and it prints out each of the arguments that we gave it. So you can imagine you have a script and you want to run it on different files every time. So what you could do is you could have a script that takes a file name and does something with it. And it doesn't have to be the same file all the time. It's not hard coded into the script, but then you can work on any file that you have, right? So that can be pretty useful. Okay, so that pretty much wraps up what I wanted to cover for this lesson. There's one quick thing that I want to show that might be useful. So we've done a lot of commands over the past like 40 minutes or so. So you can type, sorry, that was history, type history, and you press enter. It'll just kind of show you all the commands you typed previously. And that might be pretty useful because if you want to save these and look back at them, maybe you found one that was pretty useful and you want to go back and look at it. You can put that into a file. Maybe you don't want all of your history, and I'll just maybe do the last 30 lines or so. So history space 30 tells it the past 30 lines, and you can put it into a file called commands today.txt. And then if we look at our commands today.txt, it'll list all our history. So then it's a good way of like you ran all these different things while you're troubleshooting, and then you forgot what you did. If you just do this when you know that you might want to come back to it, then you can go back and see the different commands that you did and the order in which you did them, just in case you need to rerun something and you don't remember how to do that. Does everyone have that? So you can save whatever you typed today, and then you can go back and look at it and take some notes or something. But this will also obviously be posted online, and this is just taken all from various lessons that UFT Coders has already run. So you can take a look on our website for that. Does anyone have any questions about or things you might want to see that I might or may not be able to answer? Good. Okay, great. So